Okay. My fault. That's on me. All right. I fixed the problem. That will not happen again. Many apologies. I forgot that the audio board was still on. That one's on me. My fault. I apologize for breaking everyone's eardrums there for a second. And for the streamers, too. That's going to be an unexpected moment. You guys are awake now for sure, aren't you? Yeah. Okay. So for the last couple weeks, we've been spending a lot of our time looking at the process of making a character, right? Going through and understanding the basic topological creation method for characters. And it's been, I think, a journey for all of us. As you continue this journey, remember the artistry and just the technology of making 3D models and creating 3D character models is intense. Don't give up on it yet. This is going to take years and years and years of dedicated study. Okay. This is not a simple process. It's not easy in any sense. I never sugarcoat it. I try to keep a healthy dose of reality with everything that I do when it comes to computer graphics. You are going to need to continue working on this. There are a lot of really great resources out there that will help you take that next step. I think I've given you a pretty solid foundation, an understanding of the process and the sequence that we need to go through. But just know that you're not done yet. There's more to learn. And our conversation, or let's put it this way, the rabbit hole goes very, very deep, okay, when it comes to character modeling. However, today we need to kind of transition a little bit because we're wrapping up the quarter and there's one final big output of this class that we're trying to achieve, and that's how to create an internal mechanical system that's going to bend our characters. If you take a step back and look at what we've done, we've created a hollow mesh, right? There's nothing on the inside of our character that's physically going to drive its motion, right? It's a static piece of sculpture at the moment, okay? Think about what the stop motion animators from the 30s and the 40s had to do, right? Did you guys ever see the original King Kong? Right? Pretty amazing work, right? What did the folks in that era have to do to make King Kong actually physically move? What did they start with?
A guy in a suit.
It's not a guy in a suit, actually. King Kong, the original King Kong. The first thing they built was a mechanical structure, right? A mechanical skeleton, right? That had a whole series of ball joints. They're very stiff ball joints that they could pose into a whole series of different kind of, really kind of cool character poses that they could photograph using the stop motion animation process. And then on top of that armature, that's what it's called, they'd place clay and latex and foam to kind of build out the volume of King Kong, of course putting hair on the outside to give him some texture to recreate each individual strand of hair. But on the inside of that sculpture was an armature, a skeleton, that physically allowed that character's body to move and bend into form. Okay? We fundamentally have to do the exact same thing. At the moment, our characters are hollow. There's a piece of sculpture. Now it's our responsibility to go in and create that internal skeleton system. This process is called rigging, by the way. So other folks call it articulation. It's the exact same thing. Okay? It's the placement of an internal machine to drive an action, to drive a deformation of our character. So you're going to be making a simple character rig, and this is going to be pretty simple, okay? I've given you guys a really fantastic, simple little model to look at. It's in the resources section of our assignment sheet. You have until next Tuesday morning to kind of get this stuff taken care of. I'm going to give you some time in class on Thursday to smash the bugs in the rig and start, hopefully finish it up, okay? So you got about a week to do this. Let's look at the character model real fast. It's a pretty cool one. I didn't model this one. It's been around in our world for a long, long time. Little green dude. There we go. Let's take a look-see at it. There it is. There's our character. Okay. So we need to place an internal system on the inside of our green dude to make it work. All right. So the days of modeling are over. Okay. And now it's time to create a whole series of bones, and specifically joints. Before we jump into the details of the character rigging process inside of Maya, I think it's important to understand that this is a very, very Maya-specific workflow. The tools and the techniques and the sequence that we need to go through are kind of locked to Maya. This is the one part of our animation process that is not cross-platform. It's not universal. I can't take a rigged Maya model and send it over into Modo and have that rig work. Same with other apps. This is the unfortunate, until Pixar comes up with some sort of universal rigging platform, right? This is very proprietary. It's locked to Maya, Okay, there are 1,000 different ways to make a rig. I'm going to introduce to you probably the simplest application of this. At the high end, right? Rigging is an art form. It's probably the most technical art form in the entire studio because you're literally creating a machine. Okay, the technology is intense. It's not artistic one bit, which is unfortunate, but it's a necessary evil. At the high end, you can create some pretty fantastic effects. So going back to what we were talking about at Game Developers Conference, they had that Finding Dory thing. Did you guys see Finding Dory? Go see Finding Dory if you haven't seen Finding Dory. It's a really fun film. It kind of lives in the specter of Finding Nemo. It's similar but different, right? But it's still a tremendous amount of fun. And of course, for me, the character in Finding Dory that stole the show was Hank, the octopus, right? I loved Hank, the octopus. He was fantastic, right? Now, if you think about an octopus, what basic simple shape is an octopus? Yeah, he's a sphere with a whole bunch of what? Yeah, with 8 cylinders coming out of a sphere, right? You'd think on the surface that would be a pretty easy character to create and to rig and animate, right? I was blown away when I heard this. How long it took them, to rig Hank. And this not to create the model, but just to come up with the internal machine that's going to deform Hank. How long did it take them? 2 years. 2 years to figure out how to make the machine to drive Hank. That's how complex this art form can really, really get. Okay? So you're only going to see about 1% of the technology that's available to us. The purpose of this kind of rig and why we're doing it here is to give you guys a nice structure, a foundation, so that if you wanted to make a character for your final project and like pose that character in some like awesome ninja move, you can be able to do that, right? Because we always model everything in what's called the T-pose, right? This is the T-pose. Why do we model stuff like this? It's easier, right? We have the character with all of its appendages at its extreme pose, right? Hard to model someone in the Heisman pose, right? Easy to model someone like this, okay? We want to model like this, create a skeleton, and then deform them into that, right? Because that's easy. Okay. Let's get into it, okay? The sequence here is something that we have to follow, okay? This is probably the most important part about the rigging art, the rigging art, is we have to go in sequence. If we deviate from that sequence, the machine may or may not work, okay? And I like to think of it as a machine. We're creating a deformation machine on the inside of our characters. Okay, first thing first, we need to change our interface ever so slightly. Now that we're advancing into a new part of our workflow, we need to change all of our top-level menus. So instead of being in the modeling menu, I'm going to go into the rigging menu. Okay, and specifically, what we yield in this is this big skin, deform, and constraint pull-down menu at the top of the scene. That's really what we're going for in this. In addition to changing the top-level menus, we're also going to go into the rigging shelf, and you can see mine right here. This is going to bring to the surface all the wonderful rigging tools that we have inside of Maya. I actually really like the Maya rigging tools. They're pretty neat. They're simple yet powerful, which is kind of what you want to have in almost all of your tools. If we cruise over to the screen left side here, these in here are the ones that we're really going to be primarily focusing on, these 3 tools. This one's going to create a locator for us. A locator is just a point in space. We're going to use these locators to drive certain elements of our rig. You'll see that for the knees here in a minute. Okay? Really where the lion's share of our work is going to end up is on that middle one. This is where we're going to create a joint. Okay? Now, I really want to kind of enforce the idea that what we are creating here are joints, points of rotation within inside of the skeleton itself. We're not creating bones. If you really kind of take a step back, if we were to rip the skeleton out of our body, which is kind of a weird thought to think about, but if you did, right, what's actually moving? If I was to bend my elbow, what is anatomically, what is physically moving? What's the one part that's rotating? Yeah, the joint itself, right? And the bone in between my elbow and my wrist, it's kind of coming along for the ride, right? It's not actually really doing anything. The muscles and the tendons are physically moving this part of my body. The bone in between comes along for the ride. So we're making joints. We're making points of rotation inside of our mesh. These points of rotation should, as much as we can, replicate our own human anatomy. The more that we can make it sense and bring it back to us, the easier it is going to be for us to understand the function and the role of these joints. Okay. So there's a couple things in here that we're going to do. Okay, so the joint tool is going to be one that we're going to be using. We're going to get to this one here in a couple minutes. This is the IK Solver tool. That's going to make some really fun animations for our hips and our legs. But let's spend some time really fleshing out the joints. Okay, now to help you out, I've given you guys a really great piece of reference. Return back to Canvas for a second here. Under the week 9 module, and I can't believe it's week 9 already. Is anyone else freaking out that it's week 9? Yeah, we're almost done, which is kind of bonkers, right? Under the week 9 module, check this out, the character bone placement reference. You're welcome, by the way. Okay. You're welcome. I've given you guys a great map as to where all of these joints are going to be placed. Before we just start clicking and adding these joints into the scene, though, I think it's important to understand that what we are creating here is a hierarchy, right? Okay, let's put on our academic hats for a second. What in the world is a hierarchy? I like it, kind of existentially, through the lens of 3D modeling. There's certain bones or certain things inside of our scene that are more important than others, right? Now, there are examples of hierarchies all over our world. What would be one of those? Let's bring it back to computers for a second, because we work with hierarchies every single day. Every single day that we open up a computer and work with folders and files, we're working in a hierarchical system, right? If you think about it, a lot of us, we create folders, right? I do this for all of my work. This folder will be like, I name it like TCS 130, right? And then, because I'm an organizational super nerd, and I am, my wife will attest to that, I have, each week has its own folder, right? So then inside of TCS 130, I'll create another folder, and this will be, week 1, and I'll have another one that's week 2, okay? But maybe inside of week 2, I have, 4 or 5 other folders that I put in here to continue organizing all of my stuff. We have created hierarchy, okay? TCS 130, that's the parent, okay? It's the root of our entire hierarchy. Where the parent goes, so does all the children folders, right? I can take these lower level ones and change their locations without messing up the parent, right? But the hierarchy always starts at the top and feeds its way down to the bottom, right? Where the king or queen goes, so does the serfs and peons, right? Okay? Hierarchies. We're doing the exact same thing with the bone structure that we're about to create. We're going to create a simple hierarchy. Okay? Now, where we start our hierarchy and how we drive and continue to develop it is really kind of important. The first joint that we're going to create is called the root joint. Okay? This is the king. This is the top of our hierarchy. And everything is going to branch from it. It is the TCS 130 folder that I have on the whiteboard. Okay? This is the root joint, the parent. The king of the kingdom, okay? Now, and then, once we establish the root, we're going to go up and draw the spine. The spine's going to be the first thing that we create, because hierarchically, all of these other joints are naturally going to be connected to the root joint, right? And if you go back to the kindergarten, this is always kind of fun, because we are literally doing the neck bones connected to the head bone, shoulder bone connected to the spine, all that, that we're literally doing that, okay? We're creating a hierarchy, right? Because all the bones on the inside of our body are all obviously interconnected to each other. So we're going to do the spine first. We're going to flush out all those together real quickly, and then we're going to go in and do the arms and the legs, okay? Now, the arms and the legs are kind of fun. And specifically, if you take a step back and look at it, they're mirrored copies of each other. It's not about working hard, it's about working smart, okay? I want to make one side, I want to make my left arm and my left leg, and then I'm going to mirror all of that geometry across the x-axis to get the other arms and the other legs. And then once we have all the bones created and placed on the model, we're going to connect them all together to make one master hierarchy. Okay? Should we get into it? It's pretty easy. I think once you see it, you'll go, it's not too bad. Okay? So let's start with the creation of our spine. Alrighty, right. So it's best done in an orthographic view. Okay? So there's a couple things that we're going to do here, okay, inside the viewport before we start placing our joints. First and foremost, I almost always do this. I do X-ray joints. That way we can very, very easily see the joints placed on top of our models. Without this viewport property enabled, it's going to be darn near impossible to see what we're doing. So let's turn on X-ray joints and start by adding a couple joints into the mix here. Here it is right there. There's the joint tool. Bloop. All we need to do is turn it on, and now we're up and running. All right, so the root joint is going to be placed below the hips, okay? Below the hips. If you think about it in every sense, what I'm trying to create here is kind of our tailbone, okay? Not the hips, because the hips are going to be a separate element of this, right? Everything gets parented to the root bone, okay? So we got the root, and then I'm just going to visually look at the model and try to find the hips somewhere right around in here. Boop. Cool. We go back to reference. So we got root, hips, and then we got one, I mislabeled these, this is my fault. 1, 2, 3, 4 spine joints, okay? So the 4 spine joints are going to be basically kind of evened out right in here, okay? So we'll do spine 1, 2, 3, and 4. Okay? Yeah. So think of spine 4 kind of, apologize for the weird thumping sound for the live streamers, but it's going to be like right here. Kind of like if this is that little weird spot at the base of your neck, it's a little bit slightly down from there. Okay? Okay, now it's slightly down, kind of in the middle of your chest, because we need to have a bone here that represents the base of the neck, okay, the base of the head, and the top of the head. Okay, yes, sir? How did I get the arrows between the joints? The computer did that for me. So did you click off like that? Or I got the joint tool still going. Are you not getting arrows? Yours is making circles. Did you turn on X-ray joints? Yeah. Let's check it out. See what we can see here. Yeah, I think we're still gonna. Yeah, jump back. Oh, you're actually out of the joint tool at the moment. Jump back into your joint tool. Yep, there you go. Go ahead and start laying it down. Yep. There you go. Next one up.
Okay.
Yeah, there we go.
Okay, thank you.
You may want to start over. Yeah. Not that we can't fix it, it's just that it's kind of difficult to fix it. Okay? All right. So while I'm still doing, I'm just going to do base of the neck, top of the neck, top of the head. Okay? Think of it like this, and here's the strategy behind bone placement. Wherever we want an object, an appendage, part of our character to deform and bend around, we have to define that zone with a joint. Okay? So if I want to, bend my elbow or my arm right at my elbow, I have to have a joint in that location to facilitate that deformation. All right. So I'm going to hit the Q key and drop the bone tool, and let's just take a step back and analyze and inspect what we've done here. When you're working with hierarchical elements, the easiest way to kind of manage this process is to have your outliner open. And as a reminder, you can find your outliner in this button right here. Put your outliner on the left side of your interface and your OpenGL viewport on the right. Some folks, especially if you're working on 2 monitors, they like to have an outliner in a floating palette, which is just fine too. If you go up into the Windows pull-down menu, you can find the outliner there. And I'll put it in a floating palette as well. I think that's what I'm going to do just because I'm kind of working on a small screen. Now, the reason I brought up the outliner is that we need to start naming some stuff, okay? We have to be good stewards of our scene. Trust me, this is where the train derails. Because look at what we've created over here in our outliner. Of course, here's our mesh object itself, but here are all of the joints that we just created. And if you hold down the Shift key, hit the plus sign, there they all are. What's the naming convention that Maya uses when creating a joint? Just joint and then a number, right? There's no sort of contextual information in the name of the joint that gives us as the user some information as to its role. So here's my suggestion, and it takes a minute or so to do this, but it's going to pay off in the end, okay? And I really hate saying this because this is my least favorite saying. Just trust me, when we get to a stage called paint weighting, this is going to come in and have a big impact on us, okay? Because when it's all numbers, we're not going to have any sort of understanding as to its purpose and its role. We want to be able to name the joints, so let's just do it real fast. Here we go. I'm going to start at the top. That's joint 1. Now, I hate the way Maya does this. It drives me absolutely crazy. Because when you grab joint 1, since it's the parent, it actually selects all of them. Does anyone remember how to change the name? Double click, yep. Double click. So I'm going to call this root. Okay. If you followed my guide, that's hips. Let's just triple check, make sure I'm in the right spot. Yep. So that's spine 01. Spine 02. Spine, not sping. This will be neck, base. Neck, oops. Top, and then lastly, head top. I know what you're probably thinking about the head. Like, Pat, why in the world do we have a joint way up there? Last time I checked, I don't actually rotate the top of my head, and you're right. We have to have a joint at the tippy top of our chain so that we have something for the joint underneath it to rotate around. Okay? So really, this is a utility node within inside of our system that gives this one right here, so this guy, the neck top one of the one that's in the bottom of the head, something to move towards. Okay. All right. So there it is. There's my hierarchy. Now we also have to make sure that things are getting centered the way we want them to get centered. Because if you look at it, look at the joints here, they're all over the place, and that's kind of a problem for me. Okay. I want them completely centered around the origin of the x-axis. Is there a way that I can do that pretty quickly? Yes. How? Yes, the grid snapping. Good job. Okay. Here's my suggestion to you. Start at the top and the head and work your way down. Because if I was to start at the root and fire off the move tool, what happens? Yeah, the entire chain moves along with it. Okay. Because wherever the parent goes, so does the child. Okay. So if we start at the top of the head, I can move this one and get what I'm after. So I'm going to hold down the X key, do some grid snapping. It just takes a second. Oops, and I think I messed up already. There we go. All right, rock and roll. So now I'm pretty happy with that. Okay, much like in the process of creating 3D models, we align everything from one view, and then before we go any further, we align them from the next view. Okay? So I'm going to go in just real fast here, and I'm just using the move tool here. And And I'm going to start placing these, just moving them along the x-axis. Yeah, now for the spine ones, that one's looking pretty good. Now for the spine guys in here, here's what I would suggest. Try to follow and match the curvature of the back. The root bone, and I'll just start down here at the root. Here's the hips. Here's spine one. I'm going to try to place the joints matching the curvature of the back. That way we get a realistic deformation, something that kind of resembles what you'd naturally see. Now spine 4, I'm going to try to place kind of right in there-ish, which will allow me to bring the neck up to match the head. Okay? Looking pretty good. Mm-hmm. Yep. Top to bottom. Yeah, you can do it either way, but top to bottom is easiest. Yeah, just like the circle one, right? Yep. So you're good to go? Oh, yeah. That happens. So here's an idea, and I'm watching Sakura do this, and this is actually kind of a cool thing that might help you guys kind of manage what's being selected and what's not being selected, right? Because now that we have a whole series of internal kind of pieces on top of our geometry, it's very easy to accidentally grab the mesh, right? It happens, okay? Well, let me show you something. This is kind of an extension of our kind of general Maya workflow, is that we're going to place just this one mesh object on its own layer, its own visibility layer, okay? This is pretty neat. If you've ever wondered what this part of our interface is for, this allows us to create layers. Comment? It's not snapping to the grid. Just get it relatively close. Show me. Zoom in some. Interesting. Yeah. Let's keep moving. Just get it close. It doesn't have to be exactly, you know. If you just wanted to do it manually, that'd be fine too. Other comments? Yeah, question. Yeah, go ahead. Okay, drop the tool. Grab your selection tool. That'll work. But really, what we want to do is it's that one right there, the arrow. Yeah, the one right above it. Okay, cool. And let's do this. Deselect what you have by clicking in the background of your scene. Oop. There you go. Now, reactivate the joint tool. And start drawing again. That's interesting. I don't know what's going on. Yeah, I can see that the X-ray joints is on. Why isn't it allowing you? Let's do this. Let's try this. Let's try going back to our selection tool for a second. That one. I want you to go into component mode. That one. And now back into object mode. Okay. I don't know. Is anyone else having a problem inserting joints into the character? You may want to restart. Maybe it's a problem with Maya, because that's an unusual behavior, and I don't have the resolution to that off the top of my head. Yeah? No, it will do that. Yeah, I didn't. Yeah.
How do you move like this without also moving the head?
Yeah. There's a keyboard shortcut. I can't remember what it is off the top of my head. It's called compensation, where it allows us to go in and just move that one bit. Is it the V key? It may be the V key on the keyboard. We can do some digging on that and figure out what the keyboard shortcut is. I've forgotten it off the top of my head. Okay, so let's go back for a second and start talking about these visibility layers, because we're going to have a whole bunch of stuff sitting in our scene. It's not just a simple mesh anymore or a couple mesh objects. We got a bunch of stuff happening all at once now. So here's what I'm going to do. I'm going to grab my mesh object, okay? And this is kind of neat because what we're going to do is create a visibility layer over here underneath our channel box, okay? So if you select it first, it's a whole lot easier. It saves you a couple secondary steps here. There we go. If you go to the Layers section, it says Create Layer from Selected, okay? Let's just do that real fast. Let's give it a good name. Double click on it, it'll bring open this little Edit Layer pop-up menu. I'll just call this Body Mesh. Okay, you can even change the color of it. I'll just leave it as defaults. Hit Save. Okay. There we go. Now, what this yields us, and why this is important, is that we now have down here this visibility thing. Okay, so we can globally turn it on and off, which you're probably thinking, okay, that's not that cool, right? We could already do that by hiding objects. But what gets it really neat is this guy, the T, that third button in that row. Okay, that T stands for template. So we'll get a wireframe, but what am I not allowed to do when it's in template mode? Select it. Okay, let me do that one more time for the folks that were working earlier. Just go back and time a couple steps. There we go. So I start with a selection, right? I select my geometry. I go down into my display layers section of the channel box. Layers, create layer from selected. Okay? And it's that third button. That's the one that we're after. Because now, when it's on the T, stands for template, I still can see the mesh, but it's unselectable at the moment. Okay? Which is pretty neat. Okay, so now with that said, let's keep working here a little bit. I'm only going to do one half of the body, and you guys are going to go in and finish the rest of the body, okay? Because there's a lot that we have to go through this afternoon to get this to that final riggable result. All right, so let's look at our scene from the front again. And I'm going to turn off my grid just temporarily. Okay, there we go. Now it's time to start plotting down the leg itself. Okay, so we're going to create a new hierarchy now, and this is where it gets kind of fun, because we already have a hierarchy for the spine. This is one gigantic hierarchy, right? Well, we're going to create a second hierarchy that's going to be specifically used to control the leg itself. So once again, we're going to use our joint tool, and we're going to start up here at the hips. Okay, so hips, there's one for the knee. And then for the foot, it's a little bit different from the foot from the picture because I wasn't able to draw it. But the foot's going to look like this. Okay? All right, let's go in and start moving some pieces around here. Remember, if you aligned these joints in the front view, then only change their position in the side view. Now, this is important. The knee, the joint that's going to represent the knee, needs to go up towards the front of the kneecap because that's where our kneecap is, right? So it's going to be offset up here. That's an important critical element because we need to create a small little bend in our ankle in order for what's called an IK handle to work correctly. You'll see that in play here in a second. So we have to have a little bit of bend in our knee, and anatomically, that's where we rotate our knee around anyways, the front of the kneecap area. That's just Maya's way of doing it. If it is bigger, ain't no thing, because we can fix it. Something like that. Okay? Now, if you look carefully at what I'm choosing to do here, I'm creating an ankle. This is, of course, the ball of our foot, the toe of our foot. Okay? Roughly. The ball of our foot actually is, back over here at the heel, right? Or, excuse me. No, this is the ball of our foot, somewhere right around in here. And then the toe. The heel is something else. But this is a good structure for where we're going. Okay? What this allows us to do is to do this with our foot, right? We can create this cool little bend. The foot's going to be flat, but with the joint there at the ball, we can lift the heel up and leave the ball of the foot on the floor. All right, let's look at it from the front. Just triple check everything. Yep, rock and roll. This is starting to look great. Before we go any further, like we did with our spine, let's name some stuff, okay? And now that we're in the world of our legs, let's do this. Let's do, now our naming convention is really important, okay? So I'm going to do left leg, hip, okay? And let's make sure that's corresponding to with the image that I gave you. I don't want to, yep. Or let's do right upper leg. That way it's just the same as the picture. This is going to be left leg upper, okay? So this will be left knee, left ankle, left ball, let's the left foot ball, and then left foot toe. When it comes to naming conventions, the system, here's something that works really well for me. I've been doing this for years, and I think a lot of folks in our industry kind of mirror this structure. It's a good structure. And that's to start with the most general description of the role of whatever this thing is. And then after each word, we get a little bit more specific. Okay? So if you look at left, okay, so this is clearly an appendage on the left side of the body. It's the leg. And it's the joint for the upper part of that, right? Then we have left knee, left ankle, then left foot. It's the left foot. And what part of the foot? Well, it's the ball of the foot, right? Then we have left foot. Well, it's the toe of the foot. We first start off with a general description, and then we, after each underscore, we get a little bit smaller, a little bit more focused on as to its role. All right. So, it's looking pretty good. I'm liking what I have here. Shoot, I tell you what. Let's just do the arm real fast. I'm not going to do the fingers, okay? You guys are encouraged to go in and put the fingers. That's a lot of tedium that I'm not going to do at the moment. So let's just do the arms real fast. The arms are, believe it or not, the easiest part. Because if you look at it, it's just 1, 2, 3, shoulder, elbow, wrist. That's all we're doing. So shoulder, elbow, wrist. Look at it from the top. Make sure it's aligning it to the reference, and I'm pretty close. Okay. Let's name it. Left arm, shoulder. Left arm, elbow. And then left arm, wrist. Awesome. There she blows, as they say. Ready to rock and roll. And that's as far as I'm going to go skeletally with my little model. You guys are naturally going to continue working on some of these parts and pieces. Let's mirror it in. So I would encourage you to do the hands. That's the one part in here that I haven't kind of zeroed in, but I'll let you guys figure that part out. However, I want to mirror some of these joint structures. Okay, I'll do the legs. It's really easy. Before we get started, however, we need to do something that's important. We need to freeze the transformations on all of our joints. Okay, let me show you what I'm talking about here. I'm going to grab just the left leg upper joint, and let's do some analysis. Let's return to our channel box and look at all the transformations that have been applied to this object itself. Okay, specifically the position, rotation, and scale. These are important for us because what we need to create here when it comes to the skeleton is a default pose, right? A default resting kind of, it's like original position, if you will. Okay, well, all animators, they want to have their default pose be 0 on position X, Y, and Z, 0 on rotation, and then 1 on scale. Right now, I want to keep the location of these bones in their current placement inside of our 3D scene, but I need to freeze my transformation so that translate X, Y, and Z go to 0, as if the computer thinks that this location is its default location, its home location, if you will. Okay? Does anyone know how to do this? Freeze the transformations? It's really easy. From time to time, we do this in the modeling workflow. We do it all the time in the rigging workflow. We're going to go Modify, Freeze Transformations. Okay? Now, just so we're all on the same page, notice here on Translate X, Y, and Z, which is a fancy word for position X, Y, and Z, I have a whole bunch of values put in here. Okay? When I do Freeze Transformation, watch what happens to those values. Not a single thing. Let's try it again. Modify. Let's look at the option box. Oh, Joint Orient was not on. Come on. Freeze transformations. Why is that not going? Something just happened here. Train derailed. Something's changed. Oops. Yeah, what is going on here? I don't know what's going on here. Something's changed. I'm not aware of what has changed. I'll have to figure that part out. It's not a showstopper. It just makes it a little bit easier to continue working with it. Yeah, it's not doing it, but that's okay. We'll keep going, and then during the break, I'll see what's changed, and we'll go from there. It's not a critical showstopper, but it just makes animating a little bit easier. Let's mirror this thing real fast. Actually, hold on a sec. Let's do this. Let's do delete by type, history, freeze transformations. Nope. Okay. It's just going to be a little punk today, but that's okay. Let's mirror our joint hierarchy. Now, it's important that as we go through this process, I'm going to select everything because I want every single joint inside of my leg hierarchy selected so I can copy it across the x-axis. And this is really why we chose to replace all of our top menus with the rigging menus so that we can do this. We're going mirror joints, and we need to do a couple things here. Okay. Specifically, we need to look at its options because we need to tell the computer which plane to mirror this across, okay? And we want the YZ plane, so the one in the middle, okay? In addition, check this out. It also gives us a search functionality. If we didn't search and replace for joint names, watch what would happen, okay? Let's hit mirror. Too many arguments. That's fun. Mirror. This is awesome. Let's try this again. Oh, I had them all selected. You just need to have the root selected. That's my bad. So I have the topmost element in the leg selected. I had them all selected. If you just grab the root of that structure, then it would work. Without doing that mirror option, look what happens, right? Over here in the outliner, it just kind of continues. It copies the naming convention for all the original bones. Well, these are not the left legs. These are the right legs, right? So if we return to our mirror joints tool properties, let's do a little search and replace. Okay? As one might imagine, I'm going to search for left and replace it with right. Okay? That's going to change the joint names for me. I'm in the mirror joints options. So skeleton, mirror joints, tool properties, tool options. And now when I do it, let's mirror it. Yeah, mission accomplished. Right leg upper. Renamed them all for me, which is kind of nice. Looking good. Looking good. Now, if we go back and let's do the same thing for the left arm while we're here. There we go. Looking good. So there's my skeleton. Now, if you go back to the beginning of class today, I mentioned that we need to have everything hierarchically connected, okay, to the root joint itself, that one master controller. Now, for us, the root joint is actually named the root. However, we have 4 basic hierarchies that need to be connected intelligently into the system itself. I have my legs. Okay, I'm just going to middle mouse drag this up in between. There we go. So I got my legs and my arms. Okay, how am I going to connect these to the root bone itself? I need everything connected to that root bone. Does anyone remember how we can make a simple parent-child relationship? Kind of. In the mesh world, we'd combine them, right? Well, now we're actually going to do what's called parenting, okay? And parenting is the most simple relationship that we can create between objects here in Maya. And it's really easy to make a parent-child relationship. Yeah, we're going to drag and drop it. But here's the trick. We got to use our middle mouse button, okay? So I'm going to start with my right leg. And I'm going to hold down the middle mouse button and drag it on top of the word root. Boop. And check it out. See, now it becomes a child of the root, right? If you look at the way it's being visualized here, it's a child of the root. So it's got its own hierarchy still, okay? The hip has its own hierarchy still, okay? Because I want to be able to control the hips and the spine independently from the legs themselves, okay? So left leg is also going to get parented to the root. There we go. However, where inside of our hierarchy are we going to parent our arms to? Visually inside of our body, where are our arms connected to? Yeah, well, I'm going to go take it one step further. The spine 4. Okay? So the left arm gets parented to spine 4. And right arm gets parented to spine 4. Okay? And now, if you look carefully at my screen here, it's all in one hierarchy. Okay? Everything gets collapsed into one element, that root controller. Here's the hips. The legs have their own hierarchy. If we go open the hips, you can see that once we get to spine 4, we have 3 sub-hierarchies of the neck and the head, because we want to be able to control the neck and the head independently from the spine, right? And the arms have their own structure as well. Okay. There it is. If you look carefully here, the spine updates, okay? And now we have some visualizations of that connection. You can see here spine 4. We have 2 little trapezoids being drawn from spine 4 to the shoulders themselves. Coolio, huh? Okay. I'll tell you what, to let you guys kind of catch up a little bit, now's a good time for a break. We've been going for an hour and a half or so. So let's just take a small little 5-minute break, and we'll get back in, and we'll get this guy buttoned up. Okay, so before we went on break, this is where we were. Things are starting to look pretty good here. I got my skeleton all kind of dialed up where I want it to go. Just as an illustration of what we're doing here, if I grab my root bone and fire off the move tool, these two pieces are still independent from each other, right? We haven't physically glued the mesh to the skeleton yet, okay? That's a process called binding, okay? Binding, and we're going to get to that in a minute. However, I'm going to hit undo, put my skeleton back to where it is. There's one more thing that I want to do to help to make it a little bit easier to control the legs, and this is going to be the, in addition to our skeleton rig, that will help us kind of create the hinge joint for our knee, okay? Because there's two types of movements that we're going to be studying and working with in the next class in 131. You're going to hear the instructor talk a lot about forward kinematics and inverse kinematics, right? Well, forward kinematics, or a great example of forward kinematics, are your arms. That's just all rotation, right? It's all ball joints for the most part in our arms, right? Even, well, the elbow is technically a hinge, obviously, but we create the illusion of a ball joint by the twisting of our wrists, okay? All forward kinematics. We want to be able to do this, kind of these windmill motions with our arms, right? The legs, however, completely different beast, right? What basic movement, kind of type are we going to have with our legs?
Forward.
Yeah, it's just this, right? Just that kind of pump hinge movement. That's all we do with our legs, right? They're kind of like a one-trick pony. That's all they really do. And for an object like that, where we have a couple joints that are all working together harmoniously, we're going to employ what's called inverse kinematic, which creates a kind of a chain, and it tries to average out the location of the middle point inside of the sequence itself. It's pretty neat. Let's just do it real quick. What we're going to do is that with the IK tool on, we're going to click on the hip, and then we're going to click on the ankle, okay? And that's going to allow us to move the ankle and have the knee automatically move for us, okay? It's pretty cool. Once you'll see, you'll go, I got it, all right? We're just trying to simplify it. Let's actually apply the inverse kinematics to the skeleton itself. And inside of Maya, where we're going is right here. It's the joint tool with the little line below it. And you can kind of see from the icon what we're trying to do here. Really create a hinge joint for our knee. Moving the ankle will move the knee and keep the hip at its current location. Let's just do it. Let's create an IK handle by turning on the tool. And the first thing that we got to do is click on the left leg upper. Second thing is to click on the ankle. Bloop. Okay? And that's it. That's all we got to do. If you analyze the contents of our outliner, a new element has been created, this IK handle, and I'm just going to turn on the move tool with that thing selected and watch what happens. Okay? Now we grab the IK handle and the knee moves for us, which is kind of neat. Cool, huh? And the knee moves, okay? It doesn't move well, though. So let's go in and start defining maybe some additional controls, because I want to be able to control the placement of my knee. Just with that IK handle in there, it doesn't give us the compelling result that we're after. So we need to create what's called a pole vector, okay? And this pole vector is going to allow us to simply go in and control the location of our knee, and allows us to continue to twist that entire chain going up and down the leg. There's one thing we need to do first on the actual IK handle itself. So I've selected it very carefully inside of our three-dimensional scene. It's sitting right down there. It's that little line that's coming out of our ankle. FYI, probably the best way to do it is go over and just click on it in the outliner. We need to change one attribute of our IK solver in the attribute editor. So let's load it up. So I've just gone over to my attribute editor here, and specifically, we're going to go on to the IK handle attribute. These are all the attributes that physically drive, that little bit of technology, which is kind of cool. And where we're going is under IK solver attributes. Okay. Now we don't want to use the single chain solver. We want to use the rotate plane solver for our leg. Okay, and that's going to change the math, if you will. If I fire off the move tool now with that IK handle selected, It's going to give us a slightly different behavior, which is good. Okay, and it basically allows us to create the substructure for our pole vector. Now we want to control the knee with a third party. Okay, so here's what we're going to do. Let's get rid of the attribute editor. Just give me a little more real estate. We're going to create a locator, and that's what this thing is over here. A locator is just a point in space. That's all it is. It's just a cross that defines a location. That's it. Okay. However, that location is going to change the math, the solver information for our knee. Okay. Once you see it in action, you'll kind of go, "Oh, I got it." All right. First, we got to create one. Bloop. All locators are going to be placed at the origin of the scene. So let's move this thing. And I'm just going to move it roughly in line with the knee itself. And then it's going to be placed in front of the knee like this. Okay. That's it. Let's name this thing before we go any further. So this is going to be left underscore knee pole vector. So think of it like this. This is where the knee is going to point. Okay? The knee is always going to try to point to that little cross. All right. So now what we need to do is that we need to select our pole vector. Oops. I'm going to hold down the Shift key and grab my IK handle in the outliner, or you can do it visually in the viewport. That's fine. Okay? So here's how I think of it. This is going to be the driver. We select the driver first and the driven second. Okay? Parent, child. We select the parent first, child second. Okay? The locator first, the IK handle second. With those in tow, now we can go up to the top of the screen to the constrain pull-down menu, and we're going to choose pole vector. There really are no options for us to enable here, so this is where we're going. Bloop. Okay, now visually what you should see here is this cool green line being drawn, and that's the pole vector. Okay, now watch this. Question? Did it twist a little bit? Some twists are going to happen. Yeah, mine did the same thing. Completely twisted, yeah. That has probably a lot to do with the angle of the rotation angle on your foot down there. I didn't have an opportunity during a break to figure out why it wouldn't let me freeze the transformations of all of my bones. But let's just keep going, and we can smash that bug later. Okay, that's a bug. So I want to talk about paint weights here in a second before we head on out. Now the product of this, why we were going through this and trying to get it to work, is if we were to raise the pole vector or raise the IK handle, which kind of represents the ankle. Maybe I want to twist the knee. This pole vector allows us to do that. See how I rotate? It's kind of controlling the angle of my knee. My knee is always looking at that locator, which is kind of cool. Let's go back, put everything back to this default pose, and continue on. Oops, excuse me. So it really is just that easy to start getting the legs to work. The arms, we really don't need a lot of IK arms or IK chains on our arms, although we could do that if we wanted to. Last step, believe it or not. Okay, so this is a very sequential operation, and the last thing that we need to do is that we need to physically bind the mesh to the skeleton itself. Okay? This is a point of no return. Okay? You need to have your skeleton pretty dialed and ready to go before you start binding things. This is, say again? You can unbind. You absolutely can do that, right? And you can go back to the skeleton. What I was going to say is that this is usually the point where I create a new version of my project file, because I always want to have, in case the unbind doesn't work or something happens, which Maya has a good track record of doing unexpected bad things to our project files, especially when we bind and unbind things. You always want to have an unbound version of your rig. Okay, So save a new version of your project file. I usually just call it skeleton. So I know that this is just the skeleton, and then when everything is bound and everything is weighted correctly, then I make another version where it's called skinned. Okay, in my mind, that one's the version that has everything ready to go for animation. Okay, all right. So let's look at the process of binding our skeleton to the mesh itself. It's really, really easy. The first thing that we need to do, we've got to select our skeleton. Okay. Now, if you went in and created a new visibility layer for your body, you want to make sure that it's not on T or on R anymore, because we need to absolutely select our geometry now. You select the entirety of your skeleton first, hold down the Shift key, and grab your geometry. Once that's done, and you have to select it in that order, we're going to go skin. We're going to go bind skin. Now, just don't hit the button. Let's look at some of its tool properties. Okay? Because there's a couple things in here that we need to change. Okay, so these are all the tool properties. This comes with a healthy sense of exploration. Let's just put it that way. On certain characters and certain meshes, you're going to need to go in and change some of these features. Some of these things, I don't even know what they do, in all honesty. But here's the one that I almost always change, and that's max influences. Because what we're about to do in this process is assign a vertex on the mesh to the rotation influence of one of the joints. Okay? So, going back to our elbow example, I want all the verts right around the elbow to rotate when I rotate that joint. Okay? I don't want the verts on the top of my head rotating when I rotate my elbow, right? With max influences set to like 3 or 4, we're basically saying, hey, each vert can only be influenced by 3 bones, right? So maybe the bones around the arm are a good example. So the ones here in the center, I'm allowing it to be influenced by the wrist, the elbow, and perhaps the shoulder itself. Okay. Now this is done algorithmically, right? So math is going to take over and figure out how to assign all of the verts across our entire mesh to be influenced by the bones. This is an art form. The next stage is a visualization of these connections. Let's just do it real fast. So I'm going to do max influences set to 3. Let's do bind skin. Okay. Now this is the one part that I don't like about Maya, because on the surface it doesn't look like a single thing has happened, right? However, if we go in and maybe let's just go back to the feet, grab our little IK handle here, move it up. Yeah. There we go. Now we're getting the character moving with the bones themselves. Okay. Now we're not done yet. Far from it, actually. Okay. Because now we have to go through the process. Yeah. This is C here. Yeah. Now we have to go through the process of doing what's called paint weighting. Okay. And this is the laborious process. It's not fun. It's a necessary evil, as they say. But we're going to get through it, okay? Because we need to go in and inspect and double check to make sure that the verts that each bone is only influencing a certain number of verts, the area right around that bone, okay? Let's look at what we've done here. I always kind of go through and just visually inspect things, move parts and pieces around. If I grab the hip bone here, like let's do that one, and we'll just move it down, okay? We're probably never going to do that, but let's rotate the spine. So if I rotate the spine, yeah, so this is a great example. So when I rotate the spine down, I don't want the top of my thighs. If you look real carefully, see how the envelope of our mesh is kind of deflating here, okay? That's because these verts right in here are assigned to the influence of that specific joint, okay? When I rotate my spine, I don't want the top of my thighs moving. I don't want, yeah, so I got to go in and make some changes here. This is called paint weighting. There's no escaping paint weighting. There isn't. You have to do it. It's a necessary evil. The computer is just a big thinking machine that makes a lot of mistakes. It doesn't have an intelligence to it, okay? It doesn't know what it's looking at. It's just assigning verts to the closest possible joint, okay? So now we've got to go in and start making some changes to this. And it's not actually that bad. I think I'm making it sound absolutely horrible. But the tool that we're going to employ here, whoops, I just broke that chair. No, I didn't. Yes, I didn't break it. Okay, great. The tool that we're going to employ here is the paint weight tools, and you can find it right here inside of our shelf. That's the paint weight tool. Okay. Now, so you turn the tool on, and this is also something that I really don't like. You need to double click on the tool, okay? Because let's see, double click on it there. Yeah, then you'll get the actual interface itself. And we also, and this is, I got a little trigger happy here. The first thing that we need to do is that we need to click on the joints that we want to work in, okay? And I want to click on everything. There we go. So I'm going to select all my joints. Now I'm going to grab my paint weight tools, and this is why I asked you guys so very carefully to name all of your joints, okay? Because this is the area where we need to really understand what it is that we're working on. Now, at the moment, we're not seeing a visualization of all of our paint weights inside of the scene itself, and that probably has everything to do with how the interface is being drawn. So let's just walk through this interface. So we're going to see all the joints here. Everything that's influencing the deformation of our mesh is going to show up in a list, okay? We can navigate and select all these things individually, which is kind of cool. You'll see that in play here in a second, okay? And then, let's see, why are we not getting... Oh, thank you. There we go. And now, there it is. Thank you. Yeah, so I made a mistake. That's my fault. I'm thinking about another app where I got to select the joints. You select the mesh, and the mesh is going to show you the influences. Then double-click on your paint weights, because this is what we're after, right? If you look very carefully, this white band here shows me pretty directly the areas of our mesh that are currently under the influence of my left arm elbow. So the white areas are, that's a value of 1.0. So we're working inside of a range of values here. 1 means 100% influence. 0 means 0% influence. And every shade of gray in between white and black is a gradient value of influence, right? So if a vert was painted white, a value of 1.0, if I move that elbow joint, that vert is going to rotate at a rate of 100%, right? So it's going to adopt 100% of its rotation value. So if I rotated my elbow 90 degrees, the verts that are white would rotate 90 degrees. Now, if a vert had 50%, a value of 0.5 associated with their influence, what would be the rotation value if I was doing it 90? 45, right? So the ones that have a value of 0.5 are only going to rotate 45 degrees, okay? So it's percentages of influence. That's how I think of it. White and black are common values inside of our 3D industry. If you've ever done any masking in Photoshop, these white and black kind of color values are something that you're probably used to seeing. In my mind, white means on, black means off, right? So if I don't want it, like for example, check this out. So I have my left arm elbow selected. Now, if I was just to grab that elbow and rotate it, yep, that's what we get. Okay, not bad. That's not bad either. The problem child that we work in were down here. So let's grab this. Let's grab the mesh, fire off our paint weight tools again, and let's go find the joint. There's it, spine 1, hips. I think it was left leg up. Yeah. All right, let's inspect this a little bit. That's actually pretty good. Which one was it? Spine 1, is that what it was? Hip. Yeah, it is hip. Okay. Yep, hip is the one that was causing all the problems. Okay. Let's do this. Let's turn off X-ray joints. Okay. That way we can just see the mesh. Cleans it up a little bit here. And you can see pretty directly that there's some verts in here that are slightly gray. And I recognize pretty directly that on the projector, this gradient value in here is really difficult to see. You'll see it a little bit more directly on your side of the screen, okay? So I want to go in and replace a lot of these values. I don't want to have them be gray. I want them to be black. Because when I rotate or move the hip, I don't necessarily want these in here to be moving as well, okay? I want to turn off their influence to the joint. And that's where the rest of our interface down here kind of comes into play. You can change your brush profiles, which is basically the smoothness of the fall off of your brush. You can also change the size of your brush. The B key is a great way. If you hold down the B is in boy or Bravo. You can then left click and drag and change the size of your brush. Okay. And the operations here will tell you specifically what's going to happen, right? So we can replace the values that are currently assigned to these verts. We can add to them. We can smooth them out, which is going to attenuate all the values in that kind of region. I'm going to choose replace, and then the value that I'm going to replace them with is just going to be 0. Now all of these in here are going to go black. Basically saying I don't want any sort of deformation in this area of our mesh when I rotate the hips. Let's inspect the rest of the mesh here real fast. And you have to do this on every single joint because sometimes the computer will get it wrong. Okay, looking good. There's the root, hip, spine. Yeah, that's pretty good. Yeah, it looks spine 3 has some funky rotation here in the front. Sometimes the only way to really understand if it's working or not is to physically go in and grab the joints. So here's that one. Let's just rotate this forward a little bit and see what happens. Yeah, okay, so check it out. Look at how the mesh is completely collapsing right here underneath the pectoral muscles, not getting smooth deformation that has everything to do with the paint weights. There we go. So now we're in full-blown experimentation mode, okay? Let's see what we need to do here. Now, if we replace these values, see how they go back in? Now, that's not what we want, okay? Let's add a little value in. If we go to a maximum of 100, yeah, now they're starting to come out a little bit. Now, we don't want to have everything be influenced because you can see that we can destroy the deformation of our mesh pretty quickly. This is where the artistry comes in. I joke around with folks and say if you find a good character rigger, someone who understands the nuance of how the body's supposed to bend and deform, you pay them $1,000 to rig your characters, because this is the one thing that every single person in the production pipeline hates to do. And if you're good at this, you get some good job security, which is nice. Okay, I want to smooth out some of these values. So it just kind of softens the edges, the borders. You can also, let's do this. Let's do replace. I like doing this. I like replacing it with 0. I put my opacity down instead of my value down. I like replacing it with 0 and then building it up. There we go. That's pretty good. I'm seeing a sharp angle down here in the back. So let's experiment. Let's put a little bit of value in here, or take away. Actually, taking away the value worked. And you're doing this on the verts themselves. That's looking pretty good. Cool. Let's put that rotation value back down to 0, get them standing up straight. So you literally have to go through every single joint and see if it's working. Let's do this. I'm going to raise this up a little bit. Yeah, there we go. Oops, wrong button. Fire off the move tool, Pat. There we go. And now with that leg raised, I can go in and look at my geometry. So that is, let's collapse some of this. Left leg upper. And the cool thing about paint weights, or maybe the part that makes it easier. Yeah, look at that. Look how the knee just completely collapsed. That doesn't look real at all down there, right? We got to go in and fix that, okay? The great thing about paint weights, and the silver lining behind all of this, is you only have to do this once, right? Once the paint weights are done, the paint weights are done, okay? And you don't have to go in and worry about them ever again. It does take a good like 30, maybe 40 minutes of some grunt work, literally going through each individual joints and seeing which zones and areas of the mesh the joint is influencing. Okay, let's do this. Let's change this here real quick. Yeah, so I'm going to put all of these in here at 0. Sometimes what's easiest to do when you're trying to figure out what the correct values are, it completely collapse the shape, which is horrible. And there should be a natural collapsing of the folds in there anyways, right? Maybe not this much, okay? I'm just replacing the values down to 1. Sometimes sometimes very small values don't even read as a gradient gray value on the mesh itself. There we go. Okay, so now they're all back down to 0. Maybe what we can do here, grab my IK handle, reset its transformation, and then just kind of bring it up some and see how it works. Yeah, there should be a natural fold back there. Let's grab the mesh, look at the paint weights again. Yeah, I think what I'm going to do is I'm just going to soften that section there, start to blur these edges ever so slightly, smooth it out. That looks good. Then I'll rinse and repeat. Go grab that IK handle one more time. See what it looks like. Yeah, that's a lot better. That's a lot better. Okay. However, this is part of our problem, right? Yeah. The parts of my abdomen up here that are moving the way I don't want them to move. So if we check out this guy, let's look at the paint weights one more time, and then I'll let you guys do it. Come on, fingers. All right. Yeah, up here at the top, look how much influence that hip joint is having on the entirety of that hip area. Now, it needs to extend a little bit, okay? But I think we've gone a little bit too far, so I'm going to remove the influence by putting my my operation here to replace, and I'll put my value at 0. Let's just get rid of some of these. I don't want all of this stuff to work. I just want to see the hip flex. I don't want the abdomen to really move all that much. Let's smooth it out too. I like the smooth, and smoothing really helps. Creates a nice little transition in a lot of areas. Okay. Let's see what it looks like now when we move it up. Oops. Better. We're getting there. I got some work in here I got to do. There should be a natural fold right here. If you think about it, there should be a natural fold there. So I'm okay with that starting to materialize in the mesh itself. Yeah, some folks get real scared of folds because they think that the mesh is breaking. But if you really think about it, we're nothing but a whole series of folds, right? Whenever we bend our skin, it's going to fold around other parts of our body itself, okay? So this is it. This is the process, okay? This is the process, okay? We create skeletal joints. We create some additional machinery on the inside that allows us to, kind of create complex movements from very simple additions like those IK solvers and those IK handles. And then the final step is to bind and then paint all the skin weights, or to adjust the paint weights to get the proper deformation of the skin. 3 stages. 3 big stages. Okay. Our goal over the next 7 days is to get this character up and running, to rig this character, to get a basic deformation system on the interior that will allow us to get what we're after. Okay. Simple posing. And we can also animate these things too. This is how we get animation, right? Because we're not going to go in, we're not going to go in and animate polygons. That doesn't work for us, right? We have to animate at the object level, okay? So we need to have a whole series of objects that we can deform and move and change their translation information to get what we're after. Cool, huh? All right, so that's our mission over the next 7 days. You're going to get some time in class on Thursday to continue this process. Thursday is going to be an important day for us as I'm going to drop the final project on you guys, okay? And we're going to talk in detail about what you guys are going to be doing to get the final mark in this class. This is the last official homework assignment. So we want to kind of get rid of this thing ASAP so we can start transitioning our brain over to really considering what our final project is going to look like for our class. Sound good? All right. I'll see you guys on Thursday. Great job, everyone.